Welcome to the Nondestructive Testing Simulator Team Lightning Talk. Our goal was to make a simulator that mimics the job that a nondestructive testing technician does, and we hoped that this project would improve the training process for NDT operators. Here's a quick overview of what NDT is. It's a trade useful in many industries for testing for faults that would otherwise be invisible to the naked eye. There are many variations of NDT testing, but we focus on the kind seen in the picture on the right, where an operator holds a probe shooting ultrasound waves through a specimen and reads the reflections off of a screen to discern whether there are any flaws within the specimen. Current training processes are insufficient as sample specimens used to train technicians lack variations in faults that are present in real-world scenarios, and the faults can't be moved along the specimen. Our project can be broken down into three key components: a fixture, an NDT flaw detection GUI, and a probe. The fixture was designed to hold a part in place without moving. This is necessary since our probe uses relative motion from a set start point. The fixture is capable of holding parts of all different geometries, and the top block allows the UT inspector to move the probe across all sides of the part unimpeded. We tackled the issue of static position of faults on test specimens with a program that takes an STL file and converts it into a file that can have point faults added to it wherever a user clicks, allowing for a trainer to put custom faults at any location for a trainee. Our GUI looks and acts like an actual UT flaw detector. When the probe is placed on the specimen, the waveform should mimic what an operator would see with an actual NDT flaw detection system, including a bump at the far left and right of the graph representing the point where the probe is placed on the specimen, and the back of the specimen, along with any spike representing flaws within the specimen appearing between these 2 points. The CAD file from the previous slide is uploaded into this GUI. For our probe, we needed a way to track 3D position. The most cost-effective solution we came up with was an IMU. The XIO IMU3 met our needs for cost-effectiveness, and we believed we could use it to do position tracking. Since the IMU tracks acceleration, we needed to do a double integration to get the position of the IMU. Problems arose with the noise, as it is exacerbated with double integration, leading to significant drift issues. We spent many weeks thinking of solutions for these issues and eventually met with an expert through our client who gave us some valuable insights into possible solutions. However, they fell outside of time and scope for our project, though we have provided documentation of our work and notes for any future teams that may take on this project.